When the program is downloaded to the target device and placed into operation, we can observe its behavior and simultaneously monitor the program using a live communications link. Note the two videos are synced up, however there's a noticeable lag in the monitoring utility. When the green forward push button on input 3 is closed, the F contactor coil is energized, the F primary contacts close, and the motor turns on in the forward direction. You'll note the make instruction examining input I5, the F1 auxiliary contact, confirms the F contactor is actually closed and establishes a holding circuit using real-world feedback, and an operator can release the forward button. While in forward mode, the closure of the yellow reverse push button on input 4 plugs the motor in the opposite direction. You note the make instruction examining input I6, the R1 auxiliary contact, confirms the reversing contactor is closed and establishes the reversing holding circuit using real-world feedback, and an operator can release the reverse button. The stop button on input 2 is open, the reversing contactor coil is de-energized, the reversing primary contact is open, and the motor turns off. You note the make instruction examining input I6, the R1 auxiliary contact, confirms the reversing contactor is opened and drops the holding circuit. Similarly, when the yellow reverse push button on input 4 is closed, the reversing contactor coil is energized, the reversing primary contacts close, and the motor turns on in the reverse direction. You note the make instruction examining input I6, the R1 auxiliary contact, confirms the reversing contactor is actually closed and establishes a holding circuit using real-world feedback, and an operator can release the reverse button. Similarly, while in reverse mode, the closure of the green forward push button on input 3 plugs the motor in the opposite direction. You know the make instruction examining input I5, the F1 auxiliary contact, confirms the forward contactor is now closed and establishes a forward holding circuit using real-world feedback, and an operator can release the forward button. When the stop button on input 2 is open, the forward contactor coil is de-energized, the forward primary contacts open, and the motor turns off. You note that the make instruction examining input I5, the F1 auxiliary contact, confirms the forward contactor is now open and drops the holding circuit. This system behaves as anticipated for normal operation. You'll note this reversing motor starter featuring plugging action will behave identically to our previous reversing motor starter featuring software-generated electrical interlocks during emergency stops and overload events. Notably, the activation of the emergency stop or overload will drop the holding circuit and directly depower the output without reliance upon any programmed instructions to do so. When the e-stop or overload is reset, the system will return to the deactivated start state, would not immediately resume operation until directed to do so. Alright, that's about it for this quick bonus round application exercise. In conclusion, we modified and tested our previous reversing motor starter to include a software-generated push-button interlock that allows plugging action. This program operated as anticipated. Remember to review these concepts as often as you need to really drive it home. Imagine how well lab will go if you know what you're doing. Thank you very much for your attention and interest, and we'll see you again during the next lecture of our series. Remember to tell your Lazy Lab partner about this resource, and be sure to check out the Big Bad Tech channel for additional resources and updates.